Now we're going to look at how we can evaluate our logistic regression models. And we'll define 3 commonly used metrics: accuracy, precision, and recall. So the most basic evaluation metrics that we'll use is called accuracy. And that's just the number of points that you classify correctly out of the total number of points. So what fraction of points were you correct with your classification? This is a function built, like here I've shown you a written function to calculate this, but it's also built in to scikit-learn's output under just a score. Now, I'll point out this is a great place to start, but it's not always a meaningful metric, especially if you're dealing with what's called class imbalance in your data set. So let's see an example of that. Let's make a simplified example. So suppose we're trying to build a classifier to filter spam emails. And so each email is either spam, which we're calling a 1, or it's not, which we'll call ham, or a 0. So suppose we have 100 emails, of which 5 are actually spam. Here's one possible classifier. Let's say your friend says, oh, I've got a classifier for this. Let's just classify every email as not spam or ham. Okay. So based on that classifier, what would be the accuracy of this classifier? And would this be a good metric? So take a minute and think about it. All right, so I am saying every email is spam. And so 95 out of 100 times I'm correct. That's just because there were only 5 spam emails. But notice I detected none of those. So this feels like a worthless classifier because the whole point was to detect these spam emails. And this is an issue that comes up when you're using accuracy and you have a data set where you have rare events, right? So spam is a great example. Another good example would be credit card fraud, things where it doesn't happen that frequently, but when it does happen, you want to catch it. And so even though accuracy looks great here, this is not a good model because we detected none of the spam. So let's look at the other end of the extreme. Let's say you have another friend and they say, okay, I have a better plan. Let's just classify every email as spam. So now let's think about the accuracy. Now their accuracy is very low, 5%, but this classifier does detect all of the spam. So what we're realizing is accuracy as a metric, as the sole metric that you're going to use, is not helpful in situations where you have what's called a class imbalance in your data set. And that just means you have very few 1s compared to 0s. So let's identify a couple of other metrics that we can use in addition to accuracy to help us give it a better evaluation of our classifier. To start with this, we are going to create what's called the confusion matrix, which is basically just going to be a way to categorize how many of our data points did we calculate correctly, and when we were wrong, how were we wrong? So true positives and true negatives in this case are when we correctly classify an observation as being positive or negative. And I know here this is a little confusing because I'm using the word negative. Negative as in not a 1. So in this case, that's a 0. Negative means prediction of 0. This is just common terminology that you'll see with classification models. So false positives are false alarms. We're going to put them in this quadrant of the confusion matrix. This is where you predict a 1, but the true class is actually 0. And then false negatives are failed detections. So that's when you predict a 0, but in fact the true class was 1. So along this diagonal here are the data points that we have correctly classified. Now here is output from sklearn for the data set that we've been working with the tumor data. And so notice you can import this confusion matrix and just call it on your data, your Y true and your Y prediction. And so we can see in the diagonals, right, those are our true negative, true positive, so those are great. And then in the off diagonals, I can see I had 4 false positives and then almost double the number of false negatives. These numbers are so small here because I'm plotting this on our validation data set. So we're now going to talk about 2 metrics that help capture some of the characteristics of this confusion matrix. All right, so we've talked about accuracy. Now we're going to talk about precision. So precision, and the second one we'll talk about is recall. But precision and recall are 2 commonly used metrics. And so precision is saying, out of all the observations that were predicted to be 1, what proportion were actually 1? So you can think of that as how accurate is our classifier when it's predicting a positive. This metric is going to penalize false positives. So the more false positives you have, the lower your precision will be, and we want a high precision. Now recall also has 2 other names. So we'll call it recall. You'll also hear it called the true positive rate, and you'll also hear it called sensitivity. This is saying of all the observations that actually are 1 in the data set, what proportion did we predict to be 1? So how sensitive is our classifier to positives? And notice now the more false negatives you have, the smaller this will be. So this penalizes false negatives. I really like this visual of a way to understand these 2 metrics, and I did grab this off of Wikipedia. So what you're looking at here is, in the visual on the left side, relevant elements here mean the true value of the data is actually 1. So this dark green background here is all the real ones. Retrieved, so inside the circle, are the ones that we have predicted to be 1 in our data set. And so then you can see we have true positives where the greens overlap, and then I have false positives where we predict a positive but it's actually in reality negative. So if you want to think about this visual, then you can realize precision is looking at the fraction of green out of the circle, right? So out of the model predicted ones, how many of those were correct? Recall, on the other hand, is looking at this whole green rectangle as the denominator and saying what is the fraction of the actual true positives out of all of the actual data that was really 1. So this may help if it's tricky for you to remember just formula-wise. I like picturing this visual so that you get a sense of the different ways that these are summarizing our classifier. Now, ideally, we would love both of these to be close to 1. That's kind of our best case scenario. So let's go back now and look at our spam example and calculate what precision and recall is going to be in this case. So first, my precision is undefined in this case because my denominator, right, just looking at the sum of this column here, is 0. My recall is looking this way and saying, so out of a denominator of the sum of them, so a denominator of 5, how many were true positives? So what's helpful now is together, all 3 of these metrics help us realize that this classifier is not a great choice. Even though accuracy looked high, right, even though this one looks good, I have 2 other ones that look horrible. Precision and recall do not look great. And so that is a way that we're able to say, oh yeah, this is not our best choice for this model. Let's see what happens with the other case, so your other friend. So take a minute now and calculate what the precision and the recall would be. All right, so now our precision is very low because it's 5 out of 100. And our recall is very high. Okay, so our recall over here, because I have no false negatives. But again, you can think of, all right, I had 1 good metric recall, and then I had 2 very low ones, which again is telling me there's an issue with this model. So altogether, having all 3 of these gives you a more holistic understanding of your model's strengths and weaknesses. There's just a summary here. So precision is as we saw, is penalizing false positives. Recall is penalizing false negatives. And so there's going to be a trade-off. They're often inversely related. And so we'll talk about cases in which we might want to prioritize one over the other. Notice that you can achieve 100% recall by making your classifier output 1 regardless of the input, right? That's what we saw. But in that case, we had super low precision, right? So this is an example of that trade-off. So for our tumor classifier, would you recommend we try to maximize precision, recall, or accuracy? So take a minute and think about what you would consider in this situation. All right, there's not just one set answer here. I'm going to point out a possible answer. We could argue that there's a higher cost to missing positive cases because we don't want to miss any malignant tumors. And I might be okay with classifying benign tumors as malignant if this was just the first step in a process of following up with patients. If that were the case, I would be prioritizing recall. But you could also argue, right, depending on what you were going to do with this information, if you were going to start chemotherapy with this, if you were going to start giving a treatment based on the output of this model, well, then you could argue, yeah, you really don't want to be classifying benign tumors as malignant. You would lose credibility with your patients. You would end up possibly giving them unnecessary medication, right? In which case, it may be more important to prioritize precision. So this is not a clear-cut answer. This really depends on what you're using the output of the model for and how it will impact everyone involved. Now let's visit these ideas in the notebook to see how you can calculate them both manually as well as using built-in sklearn functions. All right, so now we are looking in the notebook and I am in the modeling folder, logistic regression subfolder in the logistic regression notebook. And specifically, I'm starting at the performance metrics section. So let's remind ourselves, here was the model where we left off. This was the model we just created, which, let me zoom back out so you can see. So for a mean radius, it's either predicting this tumor as malignant or benign. The blue data points are the actual data set that we have and their actual classification. So if I have a data point up here, it was actually classified as malignant. If I have one down here, it was actually classified as benign. We just added jitter so you can see the points better. And now we want to think about how well did we do. So let's think about accuracy and how we can visualize accuracy. First, we need to remember we have to pick our threshold cutoff to decide when we're going to group these as 1 versus 0. And so a default threshold where we're going to start is just 0.5. So let's go down here and we're going to visualize what this will look like. I'm going to load in my validation data set because we're going to look at both our training and our validation. Here, let's write our own function to calculate accuracy. So I want to say, out of the predictions, how many of them were correct? That's this piece. This is either going to be a true or false. And so then if I take the mean of that, that will give me the proportion or percent of data points where I was correct. And so on our training set, it's almost 88%, which is really good. And we can see this is also built in, right? You don't have to write a function. This is available to you in the model.score function. But let's visualize this. So what I'm going to do is plot the data points based on our model's categorization. And then I'm going to highlight in red any data point that we did incorrectly. So let me show you. And again, this is assuming a 50% threshold. So what did we do? What happened is we took our model and I took given data points, and if it was below our cutoff, the threshold cutoff, which for our model was 50%, which corresponds to just under 15 for the mean radius. So if it had a mean radius just under 15, our model was classifying it as benign. And if it was over 15, our model is classifying it as malignant. But there's some data points where we were wrong. So highlighted in red here, I'll circle this one, for example, is one where our model classified it as benign, but in reality, it was actually malignant. And same thing vice versa up here, our model's classifying that one as malignant, in reality, it was benign. So visually, with this plot, accuracy is saying what percentage of all these data points are green. And so we found almost 88% are green. Pretty good accuracy. Now, we expect that accuracy probably to decrease on our validation set because we didn't use the validation set to fit the model at all. So let's check what we get with validation set. I'm going to plot it here, right? So there's less data points, and again, I want to see what percent is green. And so if I do it with our function or the built-in score function, we see basically 86%. So yep, slightly smaller, but not a huge drop. So this still looks promising. But we also want to take into account precision and recall here. So this is just a reminder from the slides of how we define them, and it has the visual that I also included in the slides. And I'm writing it manually here. I will show you how we can do this built in, but for now, let's just get a sense here of the values. So this one's asking for where it actually was 1, and that's what we predicted. That's 23. This is saying where we predicted 0, and it was 0, right? So those are, our first two are good things. We were correct in our model. And then here we're seeing where we have false positives or false negatives, right? And so for precision, I want my true positives divided by true positives plus false positives, and so I see precision is pretty high also, 85%. And then recall, I'm a little bit lower, closer to 72%. Now, these are all dependent on my threshold, which we're going to talk about in the next video. So our default here was 0.5. We could talk about how we might want to adjust that, especially if we want to try to prioritize, say for example, recall over precision. Now, the built-in SciPy functions to do this is you can just import confusion matrix, and just the one caveat to be careful about is that it takes the true value as the first parameter and the predicted as the second, and so that will mix up things if you don't do that correctly. And this is outputting the matrix, but if you want to put it into an actual visual like we had here, let me see if I can get that all in ones. Okay, well, you can't see it as well here, but this is the same output that I showed in the slides, right? And where we saw we had 9 down here, we have almost double in this box versus this one, and that's being reflected in the fact that our recall is lower than our precision. So if you would like to calculate those automatically in scikit-learn, you can use precision score and recall score, and they're going to pop out the two for you also, which match what we calculated manually above. So in the next video, let's look at how we can change these values by adjusting our threshold.